Can something be true and false at the same time? Can a cat be both alive and dead at the same time? Common sense and Thomistic philosophy would say no. Nevertheless, some people argue that science says yes because of quantum mechanics and the famous Schrodinger's cat experiment. Quantum mechanics is weird. It is the most precise theory we have for describing the atomic and subatomic world, and it underlies so much of the technology that we take for granted. But many aspects of it are inherently counterintuitive. In describing the microscopic world of particles and atoms, it refuses to give definite answers to every question we might ask, but often only tells us the probability of observing various results in our experiments. Because of this inherent uncertainty, if physicists want to describe what is happening before we actually observe some microscopic phenomena, we often use the idea of a superposition. We might describe a radioactive atom as being in a superposition of being decayed and not decayed. This can very accurately describe the probability of finding said atom either whole or decayed when we actually observe it, but it is hard to get your head around what a superposition is on its own. This is the foundation for one of the most memorable thought experiments of quantum mechanics, Schrodinger's cat. Erwin Schrödinger, one of the founders of quantum mechanics, suggested that you could place a cat in an enclosed box along with a small sample of radioactive material, such that after, say, 1 hour, there's a 50-50 chance that either no atoms of the sample will decay or at least one will decay. This sample could be placed in a Geiger counter that will detect any radioactive decay, and if it does detect that decay, activate a mechanism to release hydrocyanic acid, sadly killing the cat. If we have all of that in our box, after waiting an hour, the nuclei in the radioactive sample would each be in a superposition of being decayed or not decayed. And in theory, that means that the sample of radioactive material as a whole would be in an equal superposition of having no atoms decayed or having at least one atom decayed. Similarly, the Geiger counter is then in a superposition of having been triggered and not been triggered. The acid is in a superposition of having been spilled and not spilled. And the poor cat seems to be in an equal superposition of being alive and being dead. Some people look at this sort of thought experiment and a whole host of other actual, humane quantum mechanical experiments, which involve superpositions and uncertainty about the state of things before observation, and argue that they violate the principle of non-contradiction, a fundamental aspect of classical logic, and argue that science has forced us to rethink the very way we classify what is logical. Aristotle expressed the principle of non-contradiction as, it is impossible that a thing both belong and not belong to the same thing at the same time and in the same respect. If a cat could be alive and dead at the same time, or more realistically, if an atom can be both decayed and not decayed, then hasn't this ancient principle been disproven by physics? In truth, quantum mechanics implies no actual contradictions at all. By itself, the mathematics of quantum mechanics makes no explicit claim about the cat being in some mixed live-dead state, but only gives the probability of our cat having survived once we open the box to check on her. No physicist would ever expect to observe a mixed alive and dead cat, or an atom that is both decayed and not decayed. Quantum mechanics alone makes no definitive statement about what is going on before we open the box, and further interpretation is needed to make claims about what the actual state of the cat would be before observation. And famously, there are a whole host of different interpretations of what a superposition is actually describing before we observe it. Many of these interpretations would fall into 3 broad categories. In the first category of interpretation, the cat is definitively either alive or dead in the closed box, because every atom and every particle everywhere in the universe has a definite state at all times, even if described as being in a superposition, because there is some information about that state that we do not have access to, preventing us from knowing those details. leaving us to deal only in probabilities. In the second group of interpretations, both the alive and dead parts of the superposition exist, but in different cats. The one live cat that we put into the box evolves or splits or branches into different cats, one for each possible superposition state of our experiment, and each isolated from the others in different branches of some large infinite dimensional structure. When we open the box, we ourselves are stuck on only one of those branches, and so only find one cat, either alive or dead. In a third class of interpretations, often coming under the name of the Copenhagen interpretation, and historically the most commonly cited way to describe quantum mechanics, the cat is neither alive nor dead, but is not both alive and dead at the same time either. There is no answer to the question of what happens before we open the box, of what a superposition is actually describing. The only meaningful things that this interpretation allows us to say about reality are rooted in our actual observations, and asking what happens when we are not observing is meaningless. In addition to these three categories of interpretations of what a superposition is in general, many thinkers would further reject the idea that a cat could ever be in a superposition at all. They argue that the cat or any living creature would itself be an observer. It would be the one looking in the box, and so never properly be described as in a superposition. Or that the superposition of the microscopic radioactive atoms would break down naturally in some way into a definite state once it was large enough to be a macroscopic sample or interacted with the macroscopic Geiger counter. I would argue that some of these interpretations are hugely problematic for other philosophical reasons, and there is very interesting work being done to develop interpretations of quantum mechanics that are rooted in Thomistic philosophy. But for our purposes, it is enough to clarify that quantum mechanics on its own does not violate the principle of non-contradiction, and most, if not all, interpretations of quantum mechanics do not imply a contradiction either. The weird superposition state, whether of cats, atoms, or electrons, is, at minimum, a tool for expressing the probability of observing various outcomes. Even when we survey the range of interpretations of what is actually going on in the superposition state, careful consideration shows that none actually suggest that a thing both belongs and does not belong to the same thing at the same time in the same way.